Example 19. The jib crane shown in the figure is subjected to three coplanar forces, which is provided in the figure. Replace this loading with an equivalent resultant force and specify where the resultant's line of action intersects the column AB and boom BC. So we start by finding out the magnitude of our resultant and its direction. So we start by resultant force F sub R. Okay, so the y component of our resultant force is equal to the sum of all the forces acting in the y direction, assuming upward positive, is equal to, so we have, since our 5 kilonewton is subjected at a certain angle, ratio, this is, we have, let us call this one as 5 sub y going down and 5 sub x, okay, going to the left. So we have two forces in the y direction, and that is 2 kilonewton going down and the y component of our 5. So this is negative 2 minus 5 times the y component is 4/5. So our f sub r y is equal to 5 times 1 divided by 4. It's negative 6. This is negative 6 kilonewton. And then we write our answer in following the true sense of our force that is going down. Okay, now the x component of our resultant force is equal to the sum of all forces in the x direction, assuming to the right positive. Now, although we can you can see by inspection that all of our forces is going to the left, so you can use maybe assuming all forces to the left is positive. But for the sake of consistency, I will be using to the right, assuming to the right positive. So this is equal to negative 6 kilonewton, negative 6 minus the x component of our 5, which is 3/5. 5 times 3/5. 5 times 3/5, which is equal to negative 6 minus 3, that's negative 9. This is our F sub Rx, negative 9 kilonewton. So F sub Rx is equal to 9 kilonewton to the left. Okay, so for our magnitude of F sub R, we have F sub R is equal to the square root of F sub R x squared plus F sub R y squared. And we substitute the values. X is 9 to the left, plus 6 going down, is equal to F sub R. This is 9 squared plus 6 squared. Square root answer would be 10.81665,383. 83 kilonewton. So this is our magnitude. Now for our direction of f sub r, we have theta is equal to the inverse tangent of f sub r y over f sub r x is equal to inverse tangent of. Now, we'll be using the positive values, meaning using the uh, magnitude with the correct sense already. So 6 going down, y to the left. So it's positive 6 over 9. So our theta is equal to 6 divided by 9 inverse tangent. So that's 33.6. This is 6. 690,6753 degrees going down to the left. So it means that our line of action, our resultant force, follows this path. And this is our theta. Okay, now we are like example 18, we're also tasked to find for the distances intersects the column AB and boom BC. So what we're going to do is we will copy our structure. We have, this is our column A to B, and this is our boom BC, right? Okay, from A to B, that is 2 plus 2, so that's 4 meters. So this is 4 meters. 4 meters. Okay, from here up to here. Okay, that's our boom B, column AB is 4 meters, while our boom BC is also 4 meters. Okay, this is 4 meters. Now we already know that our resultant force is going down to the left. So what we're going to do is we will let that this may be the line of action of our F sub R. So of course it follows that this is theta, this is theta. Okay, now we will let also that from A, that the distance from A, which is where our the line of action passes column AB, let us say this is our Y, right? And from A, which passes through boom BC, we'll call that our X, the distance. This is our X. Okay, so if we follow the principle of transmissibility, it means that within the line of action, we have our F sub R X going down. Sorry, F sub R Y, and we have our F sub R X. And if we use the principle of transmissibility, we can also write our force here, which has the same value, F sub Ry going down, going to the left, is our F sub Rx. right? So we can have two moments, but we can measure our moment both at A or we can have it at B. Depende lang. Okay. So let us say have a moment at point A. Because again, if you can observe that our Y is measured from A and our X is both measured from A or from B. Okay, nevertheless, we can calculate now our unknowns, which is our y and our x, which is the distances that our line of action intersects column AB and boom BC. So we do moment summation, I will use not the baga, moment summation M sub R at A. Okay, so for I will use the forces that wherein I will get my y. So kaning na diri sa ubos kaning unang f sub r x and f sub r y na to. So moment, resultant moment at A is equal to all the forces the moments that act at point A assuming counterclockwise positive. Right? Now take note that our f sub rx is counterclockwise. Okay, so that is, we have f sub rx times y and our value for our f sub rx is 9. So this is 9 times y. Of course, that doesn't mean nga wala tay f sub rx, no? Ay, f sub ry, no? Nara gyapon. So, ato lang would lamang i-represent, you know, ito ibutang, tanan. Okay, so that is 9 for our f sub rx times its perpendicular distance, which is y, plus our f sub ry nga 6. Okay, 6. Pero, wala siya perpendicular distance. Times 0. This is our resultant, right? The x and y component of our resultant is equal to, then we go back here. We have 6 kilonewton counterclockwise, 2 kilonewton clockwise, 5 sub x counterclockwise, and 5 sub y is clockwise. Okay, so we start with our counterclockwise, so that is 6 times 2. That is 6 times 2. This, okay, just to remember, yeah, this 6 is not the same as this 6, right? Because this 6 is the x component, the y component of our force, which is this one. However, this second 6 is this 6. Okay. So wait, let me erase this one. So 6 times 2 plus our 5 sub x. That is 5 times 3/5 times 1 plus 2. That's 3. 5 times 3/5 times 3. 5 times 3/5 times 3. Then minus na karon. And minus would be 2 kilonewton going down. Perpendicular distance is 1. So 2 times 1 minus our y component of our 5 kilonewton force. So that's 5 times 4/5. And then, oh, sorry. Our 5x is not 3 but 4. Okay, 5x, this is 4. This is 4. And this is 5 times 4/5 times 3. Okay, then this becomes 9y is equal to 6 times 2, that's 12. plus 5 times 3 times 4, that's 12 again, minus 2 minus 4 times 3, that's another 12. So our 9y is equal to 10, right? 12 plus 12 is 24, minus 12, it's 12, minus 2, that's 10. So divide both by 9, y is equal to 10 divided by 9, that's 1.111, or 1 repeating meter. We box this one because 1.111 or 1.1 repeating meters is the point where our where our F sub R passes through column AB, which is measured from A. Okay. So next we do moment resultant moment about point A is equal to the sum of all moments that acts at point A, assuming counterclockwise positive. But this time, we will bring our force dito sa boom BC here. This part here. Now, so that we can calculate our x, which is the perpendicular distance of our F sub ry from A. Okay. So for our resultant, F sub Rx, which is our F sub Rx from A has a distance of 4 meters, and our value for our F sub Rx is 9. So 9 times 4, 9 times 4. Oh, but before that, assuming counterclockwise positive, so F sub Rx is indeed counterclockwise, while our F sub Ry is clockwise. Okay? Okay, so this is minus our F sub Ry is 6. So this is 6 times x, which is the perpendicular distance from A. And we go back again to from A, 6 kilonewton times 2 counterclockwise. So it means we just have to copy this one. Wait, maybe I can lasso this one and just copy everything. Ayun. And paste it here. Uh-huh. Okay. This becomes 9 times 4, that this is 36 minus 6x is equal to, this is equivalent to 10, right? So this is 10. Okay, just refer to this solution that at 6 times 2 is 12, plus 5 times 3/5, that's 3 times 4, that's 12, minus 2 times 1, that's -2, minus 5 times 4/5 is 4, 4 times 3, that's 12, so that's equivalent to 10. So this is 6x is equal to, we transfer 6x here, and this becomes 36 minus 10. So 6x is equal to 26. Divide both sides by 6. So x is equal to 26 divided 6. That is 4.3. 333. or 4.3 repeating meters. So this is the distance from A or from B that where our what do you call that? Our uh resultant force passes through boom BC. Yeah. Uh sorry, it should be the distance from B, okay? Where our the line of action of our F sub R passes through point boom BC.